Hey guys, this is part 2 to lesson 4-4, and we are going to be looking at a couple of diagrams where we are showing that the triangles are congruent by doing the math on it. Alright, so this is example 3 on page 244, and what they want us to show is that triangle UVW right here is congruent to triangle YXZ if x is equal to 3. Now the first thing we need to talk about is that there's a typo in my book, which means there's probably a typo in your book. In my book, this says YXW, so cross through that W and put a Z. Alright, so again, this is example 3. We need to show that this triangle is congruent to this one, so we need to substitute that x for all the legs of this triangle and see if they actually match up to this triangle so that we can use side, side, side to show that they're congruent. So let's try it. This one would equal 3 because it's simply x. This one would equal 3 times 3 minus 5, so this one equals 4. And this one would equal 3 minus 1, which equals 2. Let's look and see. Is UV, we're going to use our math, is UV congruent to YX? UV is 4. YX is also 4, so yes. Is VW congruent to XZ? VW is 3, XZ is 3, yes. And is UW or WU congruent to YZ? Let's see, UW is 2, YZ is also 2. So yes, we've proven by the mathematics that those two are congruent based on side, side, side. All right, now let's look at, and I'm going to have to move the camera so that you can see the next diagram. I think that shows the whole thing just about. Okay, now let's look at this one. Is triangle DEF congruent to JGF? And what are we going to use to prove that congruency if so? Let's look at what y equals. It equals 7. That's what the problem told us. I'm going to move this closer just to make sure that y'all are able to see it well. All right. If y equals 7, let's plug 7 in here. Over here, we're given a side, an angle, and a side. So if these actually come out to be congruent, then we're going to be using side, angle, side to do this comparison. So let's try this one. Let's see, y equals 7. So 2 times y is 14 plus 1 equals 15. Let's try this one. 12 times 7. Let's see, I'm not going to do the math on this. Give me just a second. This one is going to be 126. So that is 12 times 7 plus 42. And this one is y squared minus 4y plus 3. And that one equals 24. So all we did was we said y times y is 49 minus 4 times y is 28 plus 3 equals 24. So now let's do our comparison. Our key or our map up here says DE should be equal to JG. DE, JG, both are 15, yes. Is EF congruent to GH? EF is 24, GH is also 24, yes. And what about our angle? This one is 126. This one is also 126. So yes, we have proven these congruent using side, angle, side. And don't forget, that had to be an included angle. All right, we are only going to do one more thing. It's actually a proof, and there is no great way for me to do this. I'm just going to lay my phone down. Y'all give me just a second, and let's walk to the other side of the room to do this proof, because I have it diagrammed on the board over here. All right, let's see. Sorry, this is not very beautifully done, but bear with me. Okay, so this proof, I need you to follow along in your book. It is example 4. It's on page 244, and this is the diagram. The proof tells us that L is parallel to M. You'll notice that that's drawn in the diagram. It also tells us that EG is congruent to HF. EG is congruent to HF. That is also drawn in the diagram. And then they want us to prove that triangle EGF, GF is congruent to triangle HGF. Let's look at that. How can we do that when we're only given one side of each triangle? Study this. Do you see any pieces of the puzzle that we've learned so far in geometry that can be applied? For example, do you see anything reflexive between the two triangles? What about FG? It's a shared leg between both triangles. It's congruent to itself by the reflexive property, so we will label it as being congruent to itself. Now notice these two parallel lines. Think about your angles with parallel lines. Are there any angles here that we could prove congruent? How about this one and this one? EGF and HFG. Those two are congruent by alternate interior angles. So now we have enough information here to prove the triangle on the left congruent to the triangle on the right. Notice what I'm going to say. By side, angle, side. Remember that angle must be included between the two sides. Side, angle, side. So let's read through this proof really quickly now that I've shown you all this information. The first thing they do is they give the two givens, of course. And then they do what I did with the angles, alternate interior angles, and then they use the reflexive property to say FG is congruent to FG, and now they have enough information to say that the two triangles are congruent by side, angle, side. So the one thing you need to be really careful here is that when you name the two triangles that are congruent to each other, that you name them in the correct order. Of course, they told you that order to name them in because they told you what they wanted you to prove, but remember that's super important that you name them in the correct order. If we're going to say EGF, then we've got to go in the same order over here, HFG, from that first congruent side to the included angle, and then up the second congruent side, or down the second congruent side, depending on the triangle. All right, that's it for this lesson. I know that I am sometimes in the video and sometimes out of the video. I'm just trying to make sure that y'all have a clear picture on the board. I hope your homework goes well, and I will see you for lesson 4-5 on Thursday.